for Lab 2, Charge Tape Revisited. So, brief introduction. The purpose of the lab is still to understand properties of charges, and this time we are creating a more sophisticated model computationally for the charge tape experiment from Lab 1. The fundamentals are still going to be the same. We're using Coulomb's law as well as the force of gravity, of course. And another concept that's going to be introduced via the coding is the distribution of charge along the tape rather than just a point charge as our model. So, brief review of the results. The magnitude of the charge calculated in the new model was 2.53 negative 4 e to the negative 4 coulombs, which is far greater than the original, which was 6.17 e to the negative 9 coulombs. So the experimental design is exactly the same as it was for Lab 1. We didn't have to redo this, we just used the results from Lab 1, but essentially you are taking some electrons away from two pieces of tape, making them positively charged, and then you're going to suspend tape 2 in the air using two objects that suspended in the air, and then you're going to put tape 1 that's also charged under it and use the distance between the two when you observe the repulsion to figure out what electric force is being exerted on tape 2. And so for this new model, some of the assumptions, we are ignoring air resistance and we are assuming equal charge distributions among and within the U-tapes, meaning the same amount of charge distributed in each tape, so we can assume that the vectors that you're going to see in the model are going to be equal. And then among the U-tapes we are assuming they have the same magnitude of charge. So what we did in this model that's different from the first one is that we're no longer treating it as a point charge. We're treating the two tapes as pieces of tape, which is how we got this model here, which is essentially a bunch of vectors that's supposed to represent the tape. And then this is tape 1, and then this would be tape 2, and this is everything acting on it, and this is sort of the sum of all of that. So that's what we did here. So we found an E field, an electric field, and then we distributed that among the pieces of tape. And then again, we used the electric field distributed amongst a bunch of different vectors. I used n equals 100 just to get a really solid line here, but you could use any one you wanted. And then we found the force of gravity and the force of the electric force as well. And this is the results. And so the magnitude of the electric force, again, from this one was 2.53 e negative 4 coulombs. And then I put in this from my last lab just so that we would have a point of comparison. It's still that 6.17 e negative 9 coulombs. So the code from Lab 2 resulted in a much more sophisticated demonstration of the real-world experiment. And again, Lab 1 treated the two tapes as point charges, whereas Lab 2 provided a more accurate model of the tape. And the reason we see a larger magnitude in Lab 2 is due to the many vectors we observe in the model representing the charge being distributed along the tape instead of just a point charge acting on another point charge. So potential sources of error, the calibrations like the length and the mass were used from the previous experiment, which is prone to the same error I described in the last lab presentation. If we had used the point charge model in this calculation, this is my answer to the what if question, then it would likely produce a very similar result as the model from Lab 1, because they would both be using point chargers in the same mass and everything like that. So the gravitational force for both of these labs was 9.51 e negative 4, which is much closer to Lab's 2 value, which makes me believe that Lab 2 was the more accurate model when comparing the two. So why do these estimates differ? Which is more likely to be close to the real value? These estimates differ because the calculations in Lab 2 are based off of an array of charges, whereas Lab 1 is based off of a point charge model. And like I said before, the calculations from Lab 2 are likely more accurate due to the fact that it's much closer to the force of gravity shown here, and that it takes into account the actual shape of the tape. And thank you so much.